Welcome to Weary Millennial After Dark. This is a little different from the usual videos. Normally we're here to pick apart bad arguments and talk about science and history, conspiracies and strange stories, and the many creative ways that humanity has managed to misunderstand almost everything. But this playlist is for something a little quieter. These videos are meant for the end of the day, for the people lying in bed with their brain still running a software update that it absolutely did not ask for the overthinkers and the late night scrollers, the tired millennials with sore backs and full calendars, and a mysterious new pain that appeared sometime after turning 30. So tonight, there are no jump cuts, no yelling, no internet comment sections, no side camera sarcasm ambush, just a calm story, a dark screen, and a quiet walk through something interesting. You can listen closely if you want. You can let it play in the background, or you can completely ignore me and fall asleep halfway through, which honestly would be one of the nicest things anyone's have ever done for my watch hours. Tonight's story is about space, one of my favorite topics. More specifically, it's about one of the strangest questions humans have ever asked. If the universe is so enormous, and there are so many stars, so many planets, so many chances for life to appear somewhere else, then where is everybody? That question has a name. The Fermi paradox. And it is one of those ideas that sounds simple at first, but the longer you sit with it, the bigger it seems to get. It starts as a question about aliens, and then it becomes a question about time, and then distance, and intelligence, then survival, and then us. So get comfortable, let the screen stay dark, let your phone sit face down if you want. Take a breath, and for the next little while, we're going to drift through the quiet universe together. Before we get to the paradox, let's start with the sky. Not the sky in the middle of the day when it's bright and blue and mostly just there. The night sky. The one people used to know much better than we do now. Before streetlights and glowing phones, before houses had little rectangles full of arguments mounted on every wall. For most of human history, night was actually dark. And when people looked up, the sky was not empty, it was crowded. Stars everywhere. A river of light across the darkness. Planets wandering slowly against the background. The moon changing shape night after night, like it was keeping some kind of ancient calendar that nobody had bothered to ask for, but everybody quietly depended on. And under that sky, people told stories. They turned stars into hunters, bears, scorpions and queens, gods and monsters, heroes and very dramatic family situations. Apparently, even the ancient sky needed a few soap operas. But underneath all of those stories was something simple. Humans looked up and wondered, what is all of that? How far away is it? Is there anything out there looking back? That last question is old, much older than rockets or telescopes, or radio signals and satellites. Long before we had the tools to study space, we had the feeling that space was not just scenery. It felt like a place, a vast place, a place with depth, a place where something might be hiding in the dark, or waiting in the light of some distant star. Tonight, that's where we begin. Not with equations or arguments, not with someone on the internet typing in all caps that they have done their own research, which is usually the mating call of a browser history full of regret. But we begin with the feeling. The quiet feeling of looking up at a sky full of stars and realizing that every little point of light is not just a sparkle. It is a sun. Some are smaller than ours, some are larger. Some are young and bright, and some are old and fading. Some are surrounded by dust, and others are circled by planets. Some of those planets might have oceans and skies, storms, mountains, ice and clouds, or maybe strange landscapes we don't even have words for yet. When you look at the night sky from a dark place, really dark, away from cities and highways and porch lights and parking lots, it can feel peaceful, but it can also feel strange. It's almost too big. The kind of big your brain refuses to hold all at once. We live on a planet that feels enormous from the ground. A single mountain can humble you. An ocean will make you feel tiny. A long road trip can remind you that even one country is too much for your lower back. But really, Earth is small. Not small to us, it's everything to us. It's every person we've ever known, every place we've ever been, every meal and argument, first day of school and bad haircut. All of it happened here, on one planet, around one star, in one ordinary neighborhood of one galaxy. And that galaxy, the Milky Way, holds hundreds of billions of stars. Not hundreds or thousands, hundreds of billions. A number so large it stops feeling like a number and starts feeling like someone spilled math all over the universe. And beyond the Milky Way, there are more galaxies. Not a few and not a lot, an almost ridiculous amount. Galaxies in every direction, scattered through space like islands of light, each one filled with stars. Each star possibly surrounded by worlds. And somewhere in that enormous cosmic ocean, the question begins to form. Quietly at first. Maybe life happened here. Maybe it happened somewhere else too. Maybe the universe is not empty. Maybe the silence is temporary. Maybe someone, somewhere, under a different sky, has looked up and wondered about us. That thought can be exciting. It can be comforting. It can also be deeply inconvenient if you are hoping to fall asleep without accidentally contemplating the entire structure of reality. Sorry about that. But stay with me. We are going to take it slowly, because the Fermi paradox is not just about aliens, it's about scale and time and probability. It's about the distance between what seems likely and what we have actually found. And to understand why the silence feels so strange, we first have to understand just how much room there is for noise. The universe is not just big. Big is too small of a word. Big is a grocery store when you forgot where they moved the coffee. Big is a parking lot after a football game, or realizing you parked on the opposite side of the outlet mall and now your knees have to file a formal complaint. The universe is not big like that. The universe is so large that every comparison gives up and quietly walks into the ocean. So let's start smaller. Let's start with Earth. Earth already feels enormous. You can spend your entire life here and barely see any of it. Most people only experience a tiny fraction of one tiny fraction of the planet. A few cities, a few states, maybe a handful of countries, a few familiar roads, a favorite restaurant, a gas station bathroom you still think about for the wrong reasons. And that's just the surface. Earth has deserts, jungles, mountains and ice sheets, coral reefs, trenches, volcanoes and forests, rivers, caves, and endless stretches of oceans where humans are very much not in charge. This planet feels like everything. But from space, Earth becomes a marble. A small blue-white sphere hanging in the dark. Pull back farther, and Earth just disappears into the solar system. The sun becomes the center of the picture. And not because the sun is special by universe standards, but because it is special to us. It is our star, our furnace and clock. The reason our plants grow and weather moves and oceans cycle. And people continue making terrible decisions at outdoor summer weddings. Around the sun, the planets move quietly in their orbits. Mercury close in, hot and battered. Venus wrapped in thick clouds and runaway greenhouse atmosphere that should make climate denial feel awkward, but somehow doesn't. Earth, the blue one. Mars, cold and dusty. Then of course the asteroid belt. Jupiter, enormous, stormy, rude enough to have a centuries-old hurricane bigger than our planet. Saturn with its rings. Uranus, which unfortunately will never have a normal day in science class. Neptune, distant and blue. And beyond them, icy worlds and comets, dwarf planets, and the long fading edge of the sun's influence. That is our solar system. It is huge. Light from the sun reaches Earth in about 8 minutes. That already feels impressive. But light takes hours to reach the outer planets. And then, once you leave the solar system, the next star is so far away that light itself takes years to get there. The closest star system to our sun is Alpha Centauri. Even traveling at the speed of light, which we absolutely do not know how to do and should maybe not be trusted with anyways, would take more than 4 years to arrive. 4 years for light. For us, with our current spacecraft, that trip would take thousands of years. Which is kind of a deeply rude thing for the universe to do. It puts the interesting stuff everywhere, and then spaces it out like it was designed by someone who hates travel planning. And that is just the nearest neighboring star. Our galaxy has hundreds of billions of stars. Imagine every grain of sand on a beach. And then imagine trying to count them. Then imagine someone walks up and says, "Good. Now, do that for every beach." That is the emotional experience of thinking about stars. The Milky Way is a vast, flattened spiral of light, dust, gas, and gravity. It is so large that light takes about 100,000 years to cross from one side to the other. 100,000 years for light. Human civilization, the whole thing from ancient cities to smartphones to whatever we are pretending LinkedIn is, fits into a tiny blink compared to that. If a message were sent from one side of the galaxy to the other and somehow crossed space at the speed of light, entire human cultures could rise, collapse, be forgotten, be rediscovered by archaeologists, be turned into documentaries, and be argued about by people in comment sections before the message ever arrived. And again, that is one galaxy. One. Beyond the Milky Way are other galaxies. The Andromeda Galaxy, the Triangulum Galaxy, dwarf galaxies, spiral, elliptical, galaxies colliding, galaxies drifting. Galaxies so distant that the light reaching us tonight began its journey before humans existed, before mammals existed, before Earth looked anything like the world we know. When we look deep into space, we are also looking back in time. The further away something is, the older the light is when it reaches us. So the night sky is not really a ceiling, it is a history book. A very large, very dark, very dramatic history book written in photons, which is a sentence that sounds like it belongs in a college course you accidentally signed up for while trying to find Intro to Bowling. And somewhere in all of that vastness, around all of those stars, are planets. For a long time, humans did not know if planets were common. Sure, we had our solar system, but we did not know if that was normal. Maybe stars usually formed alone. Maybe planets were rare. Maybe our little family of worlds was unusual. But as instruments improved, we started finding planets around other stars, then more planets, then more. Gas giants, rocky planets, planets close to their stars, planets far away, planets orbiting two stars, planets so hot they could melt metal, some so strange they sound like someone let a science fiction writer drink espresso near a telescope. And the more we looked, the clearer it became. Planets are not rare. Planets appear to be very common, which changes the feeling of the night sky. Those stars are not just lights, they are suns. And many, if not most, have worlds. Maybe dead worlds, frozen worlds, boiling worlds. Maybe worlds covered in storms or with oceans under ice. Maybe worlds that are completely ordinary by cosmic standards and completely unimaginable to us. And if planets are common, then the next question becomes hard to avoid. How many of them could support life? Not necessarily life like us, not little green people flying in saucers. Not aliens showing up in cornfields to communicate exclusively through suspiciously artistic vandalism. Just life, simple life, cells and chemistry, something that copies itself and changes and adapts, something that, given enough time, might become more complicated. On Earth, life appeared very early in the planet's history. That does not prove life is common everywhere. One example is not enough to build a cosmic census, but it does make you wonder. If Earth is not located in a special place, if the sun is not a special star, if planets are everywhere and chemistry works the same across the universe, then maybe life is not a miracle that happened once. Maybe life is something the universe does when the conditions are right. Maybe across billions of years and billions of worlds, life has started many times. Maybe most of it stayed simple, or maybe most of it died out. Maybe some of it never got past slime, which honestly still has better long-term plan than most of us did in our 20s. But maybe, somewhere, on some world, life became complex, and developed senses and movement, intelligence and tools, language, and then curiosity, then astronomy. Maybe it looked up from its own version of a shoreline or forest, desert or ocean, and saw points of light overhead. Maybe it wondered what they were and built stories around them. Maybe, much later, it built instruments and listened and called out. And if that has happened even a few times in our galaxy, then the silence becomes strange. Not impossible, not proof of anything by itself, but strange. Because the universe seems to offer so many chances, so many stars and planets, so much time, so many rolls of the dice. Yet, so far, when we listen, we hear no confirmed voices, no clear signal or undeniable message, no cosmic, "Hey, you up?" Just silence. A silence so large that it has become one of the most interesting scientific questions we have. A universe that looks like it should be full of possibility, and yet, from where we sit, seems quiet. That is the feeling underneath the Fermi paradox. Not certainty or panic, not a late-night documentary narrator whispering that the government definitely knows where the aliens are, right after a commercial for a freeze-dried emergency lasagna. Just a question. A simple, unsettling question. With this much space, this many worlds, this much time, why does the universe seem so empty? The Fermi paradox gets its name from Enrico Fermi. Fermi was one of the great physicists of the 20th century. And I know that phrase gets used a lot, great physicist. It sounds like something you say about a man in an old black and white photo who either changed the world or absolutely ruined someone's freshman year. In Fermi's case, it was both. He worked on nuclear physics. He helped build the first nuclear reactor. He was involved in the Manhattan Project. He had one of those minds that seemed to move through reality with fewer loading screens than the rest of us. But the story behind the Fermi paradox is not a story about a dramatic speech. It was not carved into stone. It was not delivered from a mountaintop while lightning struck behind him, although physicists do seem like they would enjoy that kind of branding. The famous question came up during a casual conversation. In 1950, Fermi was at Los Alamos National Laboratory talking with other scientists. They were discussing flying saucers, newspaper reports, and just the possibility of life beyond Earth. This was the early Cold War era. Rockets were no longer science fiction. Nuclear weapons had changed what humans thought they were capable of. The sky had now become a place of fear, imagination, military planning, and very expensive math. People were thinking seriously about space, thinking seriously about technology. They were thinking seriously about whether another civilization somewhere else might also learn to cross the darkness between stars. And at some point, during lunch, Fermi asked the question, "Where is everybody?" That was it. Simple, almost too simple. Not, "Please present a comprehensive, peer-reviewed framework for evaluating the probability distribution of extraterrestrial technological civilizations." Just, "Where is everybody?" Which, honestly, is probably why the question survived. Sounds like something you ask when you walk into a meeting room and realize you're either early, late, or accidentally in the wrong building. But when Fermi asked it about the universe, it became much bigger. He was not just asking whether aliens exist, he was noticing a tension, a mismatch. On one side, there's the scale of the universe, the age, the number of stars, the number of possible planets, the amount of time older civilizations may have had to arise, spread, explore, communicate, or leave traces behind. And on the other side, there is what we actually see. No confirmed signals or artifacts. No spacecraft parked politely behind the moon waiting for humanity to stop being weird. No obvious evidence that a technological civilization has visited Earth, settled the solar system, or filled the galaxy with unmistakable signs of its presence. So Fermi's question sits right between those two ideas. The universe looks like it should have room for company, but we do not see the company. Where is everybody? That is the paradox. And a paradox is not necessarily a contradiction that breaks reality. It is often a place where our expectations and our observations do not line up. And this one is especially interesting because both sides feel reasonable. It feels reasonable to think life might exist elsewhere. Earth is not at the center of the universe. The sun is not unique. The Milky Way is not unique. The chemistry of life is made from common ingredients like carbon, hydrogen, oxygen, and nitrogen. The universe is not exactly hiding those in a locked cabinet. And we now know planets are common around other stars, so the idea that life might exist elsewhere does not feel outrageous. Honestly, the opposite feels a little suspicious. A universe this huge, this old, this full of worlds, and only one planet with life? That might be true, but if it's true, it is strange. And at the same time, it also feels reasonable to look around and say, we have no confirmed evidence yet, no signal we can point to and say that is definitely not natural. No artifact we can hold up and say that was definitely built by somebody else. No visitor stepping out of a spacecraft with a helpful instruction manual and maybe a polite apology for the cattle mutilization rumors. Nothing confirmed, nothing clear, nothing that survives serious scientific scrutiny. So, both sides remain in tension. There might be life everywhere, but we have not found it. There might be intelligence out there, but we have not heard it. There might be civilizations older than ours by thousands, millions, or even billions of years. But the sky remains quiet. That is the puzzle. And the puzzle becomes even sharper when you think about time. The universe is about 13.8 billions of years old. Earth is about 4.5 billion years old. Life on Earth began billions of years ago. Human civilization, depending on where you draw the line, is only thousands of years old. Modern technology is younger still. Radio communication, barely over a century. Spaceflight is younger than some people's grandparents, which is humbling and also a little offensive. We like to imagine ourselves as advanced, and in many ways, compared with every other species on Earth, we are. We built cities and satellites, split the atom, and mapped the human genome, and sent robots to Mars. We invented air conditioning, which is arguably civilization's strongest argument in its own defense. But on a cosmic timeline, we are brand new. Not young, but brand new. If the history of Earth were a single day, humans would arrive extremely late. If the history of the universe were a calendar year, all of recorded human history would be crammed into the final moments. We are the new people in the neighborhood, immediately wondering why no one brought us a welcome basket. So, Fermi's question is not just, why are there no aliens? It is also, if other civilizations started earlier, where are their traces? A civilization only a little older than ours might not matter much, but a civilization 1,000,000 years older? 10 million? 100 million? It's hard to imagine. We have gone from the first powered flight to a spacecraft leaving the solar system in just over a century. That does not mean progress always continues smoothly. Does not mean every civilization becomes spacefaring. It definitely does not mean intelligence comes with wisdom, as any quick visit to the internet will confirm. But if even one civilization became capable of spreading between stars, and if it had enough time, then maybe we should see signs. Colonized systems, artificial structures, unusual energy use, signals, probes, something, anything. The galaxy is old, much older than we are. There's been time, so much time. Enough time for civilizations to rise long before Earth had humans. Enough time for them to explore, enough time for them to vanish. Enough time for their messages to travel. Enough time for their ruins to cool in the dark around distant stars. And yet, from here, sitting on our small blue planet, listening with young instruments and impatient brains, we have found no confirmed evidence. That's why the question lingers. And not because it proves we are alone, it does not. Not because it proves aliens are hiding, doesn't do that either. Not because it proves the government has a spaceship under a desert somewhere guarded by 3 guys named Rick. It does not. It lingers because it's honest. With everything we know, with all the stars above us and all the planets we now suspect and have confirmed are out there, with all the time the universe has had, where is everybody? The question is quiet, but it echoes. It echoes through astronomy and biology, through physics and philosophy, through every search for a signal and every telescope pointed at a distant world, through every mission that asks whether Mars once had life, every discussion of oceans under the ice of Europa or Enceladus, through every thought experiment about civilizations older than ours, and through every person who has ever stood outside under a dark sky and felt, just for a moment, that the universe was either very full or very empty. The Fermi paradox lives in that feeling. The space between possibility and silence, between what might be true and what we have not yet found. To understand why Fermi's question feels so powerful, we have to spend a little time with the math. Not scary math, not math where someone starts writing Greek letters on a board and suddenly your soul leaves your body. Gentle and sleepy math. The kind of math that mostly just asks, how many chances does the universe get? That's really the heart of it. The Fermi paradox is not built on the idea that aliens definitely exist. It's built on the idea that the universe seems to have an enormous number of opportunities for life to begin. And when there are enough opportunities, even unlikely things can start to feel less impossible. Imagine flipping a coin once. Getting heads is not surprising, getting tails is not surprising. Either one could happen. Now imagine flipping a coin 10 times. You start to expect a mix. Now imagine flipping it 1,000,000 times. At that point, patterns that would seem strange in a single flip become normal across huge numbers. The universe, in a way, has been flipping coins for a very, very long time. Stars forming, planets forming, chemistry happening, worlds cooling, oceans gathering, molecules bumping into one another in warm little ponds, deep sea vents, icy moons, or places we've not even imagined yet. Most of those worlds may be lifeless. Many may be too hot or too cold, too violent or dry or unstable, too close or too far from their star, or just too unlucky. The universe is not exactly gentle. It does not tuck planets in at night and whisper encouraging things about their long-term habitability. But there are so many planets, so many stars, and just so much time. And that is where the math starts to matter. In 1961, an astronomer named Frank Drake tried to organize this question into a kind of cosmic checklist. His equation later became known as the Drake equation, and it was not meant to give one perfect answer. It was not a magic alien calculator. You do not plug in a few numbers and get, "Congratulations, there are 47 civilizations and 3 of them have podcasts." The Drake equation was more like a way to think clearly, a way to break a giant question into smaller questions. Instead of asking how many civilizations are out there all at once, Drake asked how many stars are being formed, how many of those stars have planets, how many planets might be suitable for life, how often does life actually begin, how often does life become intelligent, how often does intelligent life create technology we could detect, how long do those technological civilizations last? That last question is the one that quietly walks into the room and kind of ruins the mood. How long do civilizations last? We will come back to that later. For now, the important thing is that Drake gave scientists a way to sort the uncertainty. Some parts of the equation are easier to estimate than others. We can study stars and count them and watch them form. We can detect planets around other stars. Over the last few decades, that part of the equation has changed dramatically. For a long time, we did not know if planets were common. Now we know that they are. That does not mean that Earth-like planets are everywhere. It does not mean life is everywhere. It does not mean anyone is sitting on a moon somewhere accidentally falling asleep to a 3-hour dark screen video about us. But it does mean planets are just a normal part of the universe. Stars often have companions. Worlds seem to be part of the standard cosmic furniture. And that matters, because every planet is a chance. Maybe a bad chance or a tiny chance, but a chance that goes nowhere. But it's still a chance. The harder parts come later. We do not know how often life begins. That is a very important sentence. We do not know. Earth is the only example of life that we have confirmed. That makes the math a little frustrating. It's like trying to figure out how common coffee shops are in the universe when you have only ever visited one town and it happens to have a Starbucks on every corner. Maybe that means coffee shops are very common. Maybe it means your town is weird. Maybe the universe is mostly empty and you just live in the one place where everything aligned. We don't know yet. On Earth, life seems to have started fairly early after the planet became suitable for it, and that is interesting. It might suggest life appears easily when conditions are right, or it might just be a coincidence. A sample size of 1 is very dramatic little data point, but it's still only 1. Then there's intelligent life. That's a different question. Life on Earth existed for billions of years before anything built a radio telescope, a city, or a customer service phone tree, which remains one of our least defensible inventions. For most of Earth's history, life was microscopic, simple and quiet. No tools or technology. No one staring into the sky wondering about distant civilizations. Just life doing what life does. Surviving, dividing, changing slowly, filling oceans, changing the atmosphere, wading through deep time. Complex life took a long time. Intelligent life took longer. Technological civilization took longer still. And even here, on the one planet where we know it happened, it almost did not look inevitable. If you rewound Earth's history and let it run again, would humans appear? Would intelligence like ours appear? Would species build telescopes or invent radio? Would anyone ask where everybody is? We don't know. Evolution does not appear to move toward a planned destination. Does not sit down with a clipboard and say, all right, bacteria first, mammals later, then eventually a species that gets emotionally attached to phone chargers. Life just adapts to conditions, branches and experiments, gets wiped out, starts again. Does not promise intelligence. So, even if simple life is common, intelligent life might be rare. And even if intelligent life is common, technological life might be rare. And even if technological life appears, it may not last very long. That is why the Drake equation is both very exciting and very unsettling. Depending on what numbers you choose, the galaxy could be full of civilizations, or almost empty. Change one assumption and the answer swings wildly. If planets are common, that pushes the number up. If life begins easily, it goes up again. If intelligence is rare, it drops. If civilizations destroy themselves quickly, it drops hard. If technological societies last for millions of years, the galaxy might be full of signals. If they only last a few centuries, we might keep missing each other like ships passing in a very large, very dark ocean. That is one of the strangest possibilities in my mind. Maybe the universe has had many civilizations, not one or two, but many, just separated by time. One civilization rises, listens, calls out, disappears. A million years later, another one does the same thing, then another and another. Each one briefly lighting a candle in the dark. But space is too vast, time is too deep. The candles do not overlap. No one hears anyone else. Not because the universe is empty, but because timing is cruel. That possibility is not dramatic in the movie trailer sense. There's no invasion or mothership. No dramatic shot of the White House, which science fiction has destroyed so many times it should qualify for hazard pay. Just missed connections. Cosmic loneliness by scheduling conflict. The Drake equation cannot tell us which answer is right, but it helps show why the question is serious. We are not asking about aliens because we saw a blurry video of light in the sky doing something that may or may not be impressive depending on how much the camera operator had to drink. We're asking because the universe is huge and because stars are common, planets are common, chemistry is everywhere, time is enormous, because Earth may not be as special as we once thought. And because if life can happen here, it's natural to wonder where else it might have happened. The math does not give us certainty. It gives us a landscape of possibilities. Some comforting, some lonely. Some frightening, beautiful. Maybe life is rare. Maybe life is common, but intelligence is rare. Maybe intelligence is common, but technology is brief. Maybe civilizations are everywhere, but quiet. Maybe we're looking the wrong way. Maybe we are listening at the wrong time. Maybe the galaxy is full of ancient ruins, silent machines, frozen signals, and worlds that once asked the same questions we do. Or maybe, for reasons we do not understand yet, Earth is one of the only places where the universe opened its eyes and looked back at itself. That's not something we can answer tonight, which is fine. Tonight is not about solving the universe. That feels a little ambitious for bedtime. Tonight is about drifting through the question, letting it unfold slowly and letting the numbers become stars and the stars become worlds, the worlds become possibilities. And somewhere inside all those possibilities, the silence remains. Not empty exactly, just unexplained. For a long time, planets outside our solar system were only an assumption, a reasonable assumption, a very good guess, but still a guess. We looked at our own solar system and saw planets circling the sun, and it made sense to imagine that other stars might have planets too. The universe tends to reuse ideas. Stars form from clouds of gas and dust. Planets form from leftover material around young stars. Gravity gathers things together. Heat builds, collisions happen. Some objects grow larger. Others are thrown away into the dark like cosmic leftovers nobody wanted to label properly in the fridge. So it seemed likely that planets should exist around other stars. But likely is not the same as confirmed. For most of human history, we could not see them. Stars are bright. Planets, on the other hand, are dim. Trying to see a planet next to a distant star is like trying to spot a firefly next to a stadium light from another continent. The planet is there, maybe, but the star overwhelms everything. So astronomers had to get clever. They could not always see planets directly, so they looked for the effects planets had on their stars. A planet's gravity tugs on its star slightly. Not much, the star is much more massive, but planets and stars actually orbit a shared center of mass. That means a star with planets can wobble. Like a giant trying to pretend a toddler is not pulling on its sleeve. If astronomers could detect that wobble, they could infer that a planet was there. Another method watches for transits. If a planet passes in front of its star, from our perspective, The star's light dips just a little. Nothing dramatic, no big cinematic eclipse, just a tiny regular dimming. A little blink, if you will. The kind of change you only notice if you are a telescope with patience, which is apparently something humans had to invent because we personally are not great at it. That tiny dip can reveal a world, its size and orbit, sometimes hints about its atmosphere, sometimes clues about whether it might be rocky or gaseous, hot or cold, strange, familiar, or completely rude to everything we expected. Once we start finding these planets called exoplanets, the numbers began to grow. At first, each discovery was stunning. A planet around another star, then another, and another. Some were huge planets orbiting incredibly close to their stars. Hot Jupiters, they were called. Gas giants so near their suns that their years could last only days. These were not like anything in our own solar system. And that was a useful reminder. The universe is not required to match our first draft. Our solar system is one example, not the template for everything. As more exoplanets were found, the variety became almost ridiculous. There are planets larger than Earth but smaller than Neptune. There are rocky worlds and gas giants. Planets with tight orbits or wide orbits. Planets around red dwarf stars. Planets and systems with multiple worlds packed close together. Or orbiting binary stars where two suns hang in the sky. Which means somewhere out there a sunset might look like science fiction, except it would not be fiction. It would just be a Tuesday. Some worlds are so hot that metal could fall as rain. Some may be covered in deep oceans. Some tidally locked, with one side always facing the star and the other side trapped in endless night. On those worlds, if conditions allowed it, there might be a narrow twilight band between permanent day and permanent dark. A ring around the planet where the star never rises or sets, just hangs near the horizon forever. That's the kind of idea that makes you realize reality does not need help being weird. Reality's doing just fine. And the more planets we found, the more the old questions changed. The question was no longer, do planets exist around other stars? The answer to that became yes. The question became how many? And then what kinds? And then could any of them be like Earth? Earth-like is a tricky phrase. People use it casually, but it can mean different things. Sometimes it means rocky, sometimes it means similar in size to Earth. Sometimes it means the planet receives a similar amount of energy from its star. Sometimes it means it sits in the so-called habitable zone. The phrase sounds very official, the habitable zone. Makes it sound like the universe has a nice little marked off area with good schools and reasonable property taxes. But the basic idea is simple. A planet in the habitable zone orbits at a distance where liquid water could exist on the surface, assuming the atmosphere cooperates. Not too close, not too far. Warm enough for water to stay liquid, cool enough that it doesn't all boil away. Liquid water matters because every form of life we know depends on it. That does not prove all life everywhere requires water. The universe may have surprises waiting. But when scientists search for life, they tend to begin with what we know works, and water works. On Earth, everywhere there's liquid water, life finds a way to make itself everyone's problem. Deep in the oceans, under ice, inside rocks, near vents where the conditions seem almost hostile, hot springs and deserts, in places that would make most of us say, "No thank you, I will be near air conditioning." Life is stubborn and inventive. Life is not always elegant, but it is persistent. So when we find a rocky planet in the habitable zone of another star, it gets our attention. It does not mean life is there, and it does not mean the planet is truly Earth-like. It might have no atmosphere. It might have a crushing atmosphere. It might be sterile and blasted by radiation. It might have water locked away where surface life could never begin. It might be technically possible and practically miserable, which is also how some people describe family vacations, but it is still a candidate, a world worth studying, a place where the question becomes a little more focused. Can something live there? Could chemistry become biology there? Could simple life begin and last? Could it change the planet? Could it leave fingerprints in the atmosphere? That last idea is important. We may not need to visit a planet to learn something about it. When starlight passes through a planet's atmosphere, some of that light is absorbed by gases. Different gases leave different marks. By studying that light, scientists can look for chemical clues: water vapor, methane, carbon dioxide and oxygen, ozone, other molecules that might suggest interesting chemistry. Some combinations of gases could be biosignatures, possible signs of life. Not proof in and of themselves. Science is usually more annoying than that. It likes to say things like consistent with and requires further study, when what you wanted was a dramatic answer and maybe a soundtrack. But still, the idea is extraordinary. A world orbiting another star. Too distant to reach, too faint to see clearly, and yet, hidden in its atmosphere, there may be evidence of oceans, weather, chemistry, and maybe life. It is difficult work, it's slow and careful. The kind of work where false alarms matter. Natural processes can mimic biological ones, and excitement has to be balanced by caution. It's not always fun, but it is necessary. Because finding life beyond Earth would be one of the biggest discoveries in human history. Even simple life, even microbes, even some distant alien slime quietly living its best slime life under a red sun. That would change everything. It would tell us that life is not a one-time accident. It would mean the universe has made life at least twice. And if it made life twice, maybe it has made life many times. That would not solve the Fermi paradox completely. Microbes do not build radio telescopes, at least as far as we know. Although, given enough grant funding, someone will probably try to check. But finding any life beyond Earth would shift the question. It would tell us that biology is not confined to our planet. It would make the silence of intelligent civilizations even more interesting. If life is common, why do we not see intelligence? If biology appears easily, why does technology seem so quiet? Are we rare, not as living things, but as thinking, building, transmitting things? Are worlds full of life, but mostly simple life? Is the galaxy green with microbes and almost empty of minds? That's one possible answer. A universe full of life, but not conversation. A universe where oceans under alien skies teem with chemistry and cells, while the stars above remain untouched by signals. There's something strangely peaceful about that possibility. It's not lonely exactly, just quiet in a different way. The cosmos might be alive in small hidden places beneath ice and warm oceans, in the mud of distant worlds or in clouds, in cracks in rock. Life without technology or astronomy. Life without anyone asking where everybody is. But then again, maybe some worlds go farther. Maybe on some planet life becomes complex. Some creatures raises its head or its eyes or whatever strange organs evolution gives it. Maybe it notices patterns and seasons, moons and stars. Maybe it learns and builds and wonders. That is what makes exoplanets feel so powerful. Each one is not just an object, it's a question mark. A world we've never touched, a place that may be dead or alive or something in between. A place where the story might have ended early or never began at all. And when you multiply that by the number of planets in the galaxy, the feeling returns. The quiet pressure behind the Fermi paradox, not certainty, not proof, just possibility stacked on possibility. World after world, orbit after orbit, star after star. So many chances, so many hidden histories. So many skies that might never be seen. Maybe somewhere, one of those skies belongs to someone else. Someone who also found planets around other stars and also built instruments. Who also learned that the universe was larger than their myths. Someone who also asked the oldest question under a night sky. Are we alone? And maybe they listened, just like we are listening. Across the darkness neither side fully understands. Once humans realized the stars were suns, and once we started to understand that planets might be common, the question became harder to ignore. People have imagined other worlds for a long time. Ancient philosophers wondered about them, writers filled them with strange civilizations, religions and myths sometimes placed beings in the heavens. Science fiction took the idea and ran with it, occasionally with elegance, occasionally with ray guns, and occasionally with costumes that looked like somebody lost a fight with aluminum foil. But in the 20th century, the question changed. It became less like fantasy and more like something science could actually approach. Not necessarily answer completely, not yet at least, but approach. The reason was technology. For almost all of human history, if another civilization existed around another star, there was not much we could do about it. We could wander and write stories and stare at the sky and have emotionally complicated thoughts, but we could not really search. Then came radio. Radio changed the problem. A civilization with radio technology could send signals across space. Not easily, not casually, not with a little walkie-talkie from a camping trip where half the conversation is just someone saying, "Can you hear me now?" Like they're personally auditioning for a cell phone commercial in 2003. But powerful radio signals can travel through space. They move at the speed of light and spread outwards. They can cross enormous distances. And once humans learned to build radio telescopes, we could do something new. We could finally listen. That was a turning point. For the first time, the search for other intelligence did not have to be pure speculation. It could become an experiment. A difficult and at times frustrating experiment, but an experiment that mostly returns silence and makes everyone involved look very patient. Still an experiment. If another civilization had built transmitters and chosen to send signals, and those signals were pointed our way, and they were strong enough, and we were listening at the right frequency, at the right time, then maybe we could detect them. That is a lot of ifs. Science, sadly, is often a large pile of ifs wearing a lab coat. But the possibility was real enough to take seriously. And this is where the expectation of company began to grow. Humans had only been using radio for a short time, and already our signals were leaking into space. Television broadcasts, radar, communications, military, civilian, a messy little bubble of human noise expanding outward from Earth. Most of those signals weaken as they spread. They're not easy to detect across interstellar distances. The galaxy is not sitting there enjoying reruns of our old sitcoms, which is probably for the best. Humanity has embarrassed itself enough without beaming laugh tracks into the cosmic record. But the point remained. A technological civilization can affect its environment. It can produce signals and use energy, alter planets, build machines, and leave traces. And if we can do that after only a short time with technology, what could an older civilization do? That question became especially powerful because humans are new at this, like painfully new. We've been using radio for just over a century. We've had powered flight for a little more than that, had spacecraft for less than a human lifetime in cosmic terms. We sent our first artificial satellite into orbit in 1957, landed humans on the moon in 1969, sent robotic probes to other planets and placed telescopes in space, explored Mars with rovers and sent spacecraft past Jupiter, Saturn, Uranus, and Neptune. A few human-made objects are now on paths that carry them beyond the planets, out toward interstellar space. And all of that happened very quickly. Not easily or perfectly, and not without disasters and failures and politics and budgets, but quickly. In a few generations, a species that once looked at the moon as a distant light left footprints in its dust. That is astonishing. So imagine a civilization older than ours by 1,000 years. Not 1,000,000 or 1,000,000,000, just 1,000. A civilization that began using radio when we were still living in the Middle Ages. What might they be capable of now? Then imagine one 10,000 years older, 100,000, 1,000,000. The galaxy is old enough for that. It's very old. Older stars formed long before the sun, older planets formed long before Earth. If life can develop elsewhere, there may have been worlds with a head start so large that our entire civilization would fit into one of their footnotes. That is where expectations begin to turn into unease. If technological civilizations are not extremely rare, and if some of them last, then there should have been time for at least a few to become very advanced. Not magical or supernatural, just advanced. Advanced the way we would seem advanced to people from 10,000 years ago. Imagine trying to explain a smartphone to an early farmer. You would hold up a little glowing rectangle and say, "This contains maps, music, books, photos, messages, games, financial records, weather forecasts, and videos of raccoons stealing cat food." And that person would probably either worship you or hit you with a rock. Both understandable. Now reverse that. What would a civilization 100,000 years ahead of us look like? Would we even recognize its technology? Would we notice it? Would it communicate in ways we understand? Would it even use radio at all? Maybe radio is just a brief phase. Maybe advanced civilizations use methods we've not yet discovered. Maybe they become quiet, stop leaking signals. Maybe they communicate through tightly focused beams or systems that look natural to us, or physics we do not yet know how to read. That possibility matters, but still, older civilizations might leave large-scale signs. Some scientists have wondered whether very advanced societies could build enormous structures to collect energy from their stars. One famous idea is a Dyson sphere, or more realistically, a Dyson swarm. Not a solid shell around a star, which sounds like a maintenance nightmare and a great way to make a star very angry. More like a vast collection of orbiting structures, like satellites and collectors, habitats and machines. A civilization that could build something like that might alter the light from its star in unusual ways, might produce waste heat, leave patterns we could search for. That does not mean such structures exist. It means that they're one example of kind of a signature an advanced civilization might create. The search for extraterrestrial intelligence, also called SETI, is often focused on signals, but the broader search can include technosignatures, signs of technology. Signals are one kind. Artificial light could be another. Unusual atmospheric chemicals, strange heat patterns, objects or structures that do not fit natural explanations, anything that might suggest not just life, but engineering. And this is where the silence becomes more complicated. We're not just asking why no one has visited. The question is loaded with assumptions. Space travel is hard. Interstellar travel is extremely hard. Crossing the galaxy may be so difficult that even advanced civilizations rarely attempt it, if at all. But signals should be easier than starships. Large-scale energy use might be visible. Artifacts might remain. Probes might travel slowly but steadily. There are many ways a civilization could become detectable without landing in someone's backyard and terrifying the dog. So why have we not found anything? One answer could be simple. We barely looked. And that's true. The galaxy is enormous. The range of possible frequencies is also enormous. The amount of sky is enormous. The amount of time we've spent searching is tiny. Saying we have not found alien signals yet may be like scooping one glass of water from the ocean, seeing no fish in it, and declaring the sea empty. And that's an important point. Our search is young. Our instruments are improving. Our coverage is incomplete. The silence might not mean the galaxy is silent. It might mean we have not listened well enough, long enough, or in the right way. But another answer could be that there really are very few civilizations to detect. Maybe life is rare, intelligence rare, technology rare, long-lived technology rarer still. The expectation of company comes from scale. The silence comes from observation, and the Fermi paradox lives between them. We expected, or at least hoped, that the universe might be noisy. Not noisy in the sense of chaos, noisy in the sense of evidence. Signals, patterns, hints, messages. Something that would tell us we are part of a larger community of minds. And so far, confirmed evidence has not arrived. The Fermi paradox can feel lonely, a universe full of stars and no clear answer. But it can also feel peaceful, because the silence above us is not hostile, it's not shouting or demanding, it's simply there. A vast dark ocean of possibility. And here we are, on Earth, a small planet, blue and white, warm in places, cold in others, covered in oceans, forests, deserts, cities, clouds, and life. A planet where matter became aware, where atoms learned to ask where they come from. A planet where living things looked up and realized the stars were suns. A planet where one species, strange and anxious, clever and exhausted, built instruments to listen across the dark. That is us. Not perfect, not finished, not always impressive, but here. For all our flaws, humans are the part of Earth that wonders. We are the part that sends questions upward, and the part that looks at silence and refuses to stop listening. There's something beautiful about that. Even if we are alone, we are the universe becoming aware of itself, in at least one place. And if we are not alone, then somewhere else, perhaps under a different sun, another form of life may be doing the same. Looking up, wondering, listening, waiting, maybe afraid, maybe hopeful, maybe tired, maybe telling its own calm story in the dark. And maybe neither of us can hear the other yet. The distance may be too great. The timing could be wrong. Signals might not have arrived. Of course, the languages don't match. Maybe the universe is full of questions traveling slowly between worlds. But questions matter. They are the beginning of every search. And this question, simple as it is, has carried us far. Where is everybody? We do not know. Maybe life is rare. Maybe intelligence is rare. Maybe civilizations burn out. Maybe they hide. Maybe space is too big. Maybe we are early or we're listening wrong. Maybe the answer is something stranger than all of those. Something beyond our current science, our current imagination, our current little window into the cosmos. For now, the stars remain quiet, distant, and beautiful. The same stars that guided travelers, inspired myths, shaped calendars, and made ancient people wonder. The same stars that led to telescopes, equations, spacecraft, and searches for different worlds. The same stars that still hang over us when the day is done and the noise finally fades. So tonight, you do not have to solve the paradox. You do not have to decide whether the universe is empty or full. You do not have to chase every possibility all the way to the edge. Just rest here for a moment on this small world, under the dark sky, with this old question. The universe is large, the night is quiet, and somewhere, light is always traveling from star to star and world to world, across distances too great to imagine. Maybe carrying nothing, maybe carrying answers, maybe carrying messages no one has heard yet, maybe carrying the first hints of a story still waiting to be found. For now, we listen, we wander, we drift, and if sleep finds you somewhere in that wandering, that's perfectly fine. The stars will still be there. The question will still be there. The quiet we'll still be there. And maybe that's enough for tonight. This has been Weary Millennial After Dark. A calm walk through the Fermi paradox, a great silence and strange possibility that we're not the only ones looking up. From here, the talking will fade, the screen will stay dark, and the rest of the night can be left to soft sound, soft breathing, and whatever thoughts decide to loosen their grip. So get comfortable, let the day fall away, let the questions drift farther out, past the room and the roof, past the clouds, the moon, Mars and Jupiter, past the edge of the solar system, out into the long dark between stars. Maybe somewhere in that darkness, there's another world, another sky, another listener, another quiet mind wondering the same thing. Where is everybody? Maybe someday someone will answer, but not tonight. Tonight, we rest in the question and let the silence be soft.